Very quickly, I think Steve gave a great intro. Nano One, we are a technology company, process technology. We're focused on lithium-ion battery cathode materials. Our technologies addresses really all cathode materials, but very specifically, we're focused on lithium iron phosphate. We'll get into a lot more detail about that. Our technology, which we call the one-pot process, drives down the cost, the complexity, the environmental footprint, the wastewater, and ultimately helps drive localization of supply chains, and which of course is of growing national interest and security interest around the world today. Without further ado, I'll jump into it. We are a TSX listed company, of course, and we will say things in here that constitute forward-looking information, forward-looking statements. Encourage you to do your homework separately from what we're doing here. Also, to keep in mind that investments are, of course, investment decisions are yours and yours only. All we can do here is provide our view and our and basically current state of information and publicly available information to you as is. We have a relatively large team, 50 people based on the west coast of Canada, just outside of Vancouver in Burnaby, and 50 people on the eastern side of Canada in just outside of Montreal in a town called Candiac. Paul, Alex, and I here on the slides will be presenting to you. The team is much larger than this. I won't get into everyone in any kind of detail here. Suffice it to say, we have a strong board of directors. We have advisors in the nickel, cobalt, lithium battery, and government relations space that have been very valuable to us in the years that we've had them on. Our chair, Anthony C, is one of the has one of the largest success stories in the lithium space today, having piloted Galaxy Lithium to commercial success in Australia, and through a number of acquisitions is now under the title of Rio Tinto. Just some very, very good experienced people here who've been in the industry anywhere from a couple years all the way out to 20, 25 years, and even longer in some cases. A bit of battery 101. I want to walk you through. The lithium-ion battery consists of two electrodes, the anode and the cathode, and they are structures graphite and other metals, graphite on the anode and nickel, manganese, and cobalt, or iron and phosphorus on the cathode. Lithium shuttles between the two electrodes as you charge and discharge the battery, passing through a separator and transported via electrolyte, whether that be solid or liquid. Our focus is on the cathode material. Essentially, it's a powder that has been pressed onto a piece of foil and either wrapped into a cylindrical cell, like you see pictured here, or folded into a flat cell like you might have in the back of your phone or laptop. The cathode is the most complex and expensive component in the lithium-ion battery, and that's because it has a whole bunch of different raw materials in it. It constitutes anywhere from 30 to 50% of the cost of the lithium-ion battery cell itself, so it is very expensive. That number will go up to 75%. We've seen when lithium prices are high, so it's largely governed by the cost of lithium, iron, phosphorus, nickel, manganese, cobalt, all the ingredients that go into making a cathode material. As I alluded to, there are different flavors. There's lithium iron phosphate, lithium nickel manganese cobalt, lithium nickel manganese oxide. These are all different types of lithium ion battery cathode materials and are used for different applications in different batteries. LFP, where our main focus is right now, is the longest lasting, most durable, safest, lowest cost of the cathodes and batteries, and it is applicable to mass market electric vehicles. It's applicable to battery energy storage systems, industrial applications, and currently reaching almost 80% market share in China. So it is really the dominant material in the world today. The nickel, manganese, and cobalt flavors are higher density, but they're not as durable and they're higher cost, typically targeted towards luxury, long-range electric vehicles. And there are various types of these materials in different combinations of nickel, manganese, and cobalt. Similarly, lithium nickel manganese oxide is a material. It's really next gen. We see it for niche applications, fast charging, very specifically fast charging applications and high power applications. It's not as dense. It runs at a higher voltage and it can be charged very quickly. And this means that basically there are a lot of different flavors of cathode materials, as we say. LFP is there is no LFP is LFP is LFP. You always have the same ratios of lithium, iron, and phosphorus in the battery. However, all of the other cathode materials can have a full range of different cathode mixes. And BNEF estimates the whole combination here will result in about 5.9 terawatt hours of demand in 2035. Just for context, that's enough for about 100 million electric vehicles, and it's enough to power every home, business, and industry in California for 8 days. It gives you a context of what that level of energy is. The the other CAMs consist of nickel, manganese, and cobalt combinations, sometimes aluminum, sometimes iron. There's a variety of different flavors. But what's consistent about all these other cathode materials is that there is an infinite number of possibilities of ways to combine, let's say, nickel, cobalt, manganese, lithium, and aluminum. And that results in many, many different niche materials. When we look at the projections out into 2035, the average market for every one of those niches is about 2.5% of the grand total you see here. So about 150 gigawatt hours. And as new formulations of, let's say, lithium, manganese, iron phosphate, LMFP, or lithium, nickel, manganese, cobalt, as new formulations come out, it will further bifurcate the markets by 2035. So we see all those little pieces of pie will probably get smaller and smaller, and there'll be more of them in the next 10 years. However, LFP will remain a very dominant material and really very consistent. The way we look at this is LFP it has about 20 times the addressable market, and about compared to any one of those cathode materials you see on the left, and also has about 20 times the economy of scale. What it means is that LFP plants will largely all be the same. That means the equipment is the same that goes into them. That means the plants can get larger and larger and larger without having to make specific new custom formulations. And this helps address a much larger market, and it reduces the cost of production compared to all the non-LFP formulations because you don't have to build a custom plant every time. And by and large, it's about 50% of the market in 2035. So that's one of the reasons we believe LFP will be very dominant. And the other reasons I explained in the previous slide were to do with safety, cost, and durability. If we break this down further into kind of the full market and how it breaks down, we see that in 2035, LFP becomes a fairly dominant part of the supply chain, and LFP in China will start to flatten out while LFP in the rest of the world continues to climb and will eventually outstrip LFP by the end of this decade, and by mid-decade it will be about 50% larger than the LFP in China, or even almost twice the size. If we look at where it is today, in terms of the rest of the world, LFP is probably a little less than it is in China today, and you can see that growth from 2025 to 2035 leads to really a mass market adoption of LFP over the next 10 years. That's the estimates for these numbers came out of Bloomberg New Energy Finance, BNEF, and they are roughly 3 times higher than they were forecasting in 2021. The spread between 2025 and 2035 amounts to about a 5x growth in LFP adoption just in the rest of the world, and that's largely driven by AI, data centers, energy storage applications, and electric vehicle applications. The total LFP opportunity in the rest of the world in 2035 is about 2.1 terawatt hours. That's 3.4 million tons of LFP. That would be a 136 of our plants that we're designing, roughly each one at about a $500 million. And the and of course, it would fuel about 35 million electric vehicles, just to give you some context. That's a $40 billion a year addressable market in the rest of the world for LFP. So a fairly big chunk of pie. I want to walk you a little bit through the market challenges that we are addressing at Nano One before I hand it over to Alex. The global market has a very real bottleneck in it, and that exists at the cathode itself, and that's between mining and batteries. Critical minerals are mined. Critical minerals are mined and refined in jurisdictions all over the world. Eventually, they are processed into high purity, let's say versions of nickel and manganese and cobalt and lithium. The cathode processing combines all of those high purity materials into a composite material that will store energy in a battery. Ultimately, those will be manufactured into cells, and then they will be assembled into larger battery packs. Those applications include AI data centers, defense and security applications, renewable energy storage, and of course, electric vehicles before they get recycled. So that's just kind of how the supply chain currently works today. However, China controls the battery materials part of the supply chain. They, by and large, control the refining, processing, purification, and cathode processing. Most of that is done in China. In January of this year, China put restrictions on the export of processing their know-how for lithium iron phosphate and lithium. And that's largely because they have a big head start on the rest of the world, and they're trying to limit the proliferation of their know-how and their manufacturing technology. In April of this year, there was an executive order put out by the U.S. administration ensuring national security and economic resilience to reduce the dependency on Chinese supply chains. So this is an emerging trend, not only in the U.S., but in jurisdictions all around the world. And then lastly, we saw the reconciliation bill, the Build Back or the big beautiful bill, and that's really on changing the IRA tax credits and further prohibiting foreign entities of concern from benefiting from U.S. tax dollar incentivization. So these are all trends that are really focused on trying to break the stranglehold that China has on the midstream. So let's walk through what that actually looks like. So the challenge is that China, first of all, has abundant low-cost sources of iron sulfate, nickel sulfate, and other things, but iron sulfate specifically from tailings. They started a titanium industry after the Second World War in China in the 40s and 50s, and a largely antiquated way of processing titanium that results in a whole bunch of iron sulfate tailings. And they have been cherry picking from that for years. Nowhere else in the world does that actually exist. The rest of the world uses much cleaner ways of processing titanium, so we really don't have access to that cheap, abundant, and almost free source of iron sulfate. China also has laxer regulations. So when they process that iron sulfate, all the sulfate comes out in the form of waste and wastewater. And laxer, really the laxer environmental regulations have allowed them to really build out their industry without having the same kind of challenge that we might have in the West. So I'm going to walk you through some of the solutions we have. It's largely our technology is what we call the one pot process. We're focused right now on LFP solutions, and we spend a lot of time talking to governments, to customers, to licensees, to industry players, to miners, to refiners, and that is the voice of the customer that has really driven our understanding of the market. So in terms of iron sulfate tailings, we are qualifying separate sources of iron, and you'll see later we have a joint development agreement and partnership with Rio Tinto, who are one of the largest iron producers in the world, and there are certain sources that are battery compatible. We believe that will help eliminate the bottleneck that China has on iron sulfate. We have our one pot process has eliminated wastewater and the use of sulfate as inputs, so that makes it easier to permit and it doesn't require us to loosen any regulations. Ultimately, China has also benefited from vertical integration, so their phosphoric acid companies and their titanium companies are vertically integrating to drive down cost and put more of the value chain under one roof. Much more difficult to do that in the West. So instead, what we've done is we've used technology to integrate different parts of the process. I'll walk you through that, and that helps drive down the cost, energy, and water use. China also benefits from economies of scale and large capacity. So they built out this massive ecosystem that feeds itself, by and large, and that means many plants, a lot of equipment, a lot of talent, and that has helped drive down the cost and improve the quality of the product. We are working on what we call a design one, build many process. And because we get rid of wastewater, we can make a modular design of our plant, and we're not so worried about where we end up siting it. That will help it deploy and scale much more rapidly, and we believe will help us catch up with China's economy of scale. China also has widespread industrial know-how. They've been at it for longer than anybody else, by and large. But we have also have here in Canada the only LFP plant outside of Asia and the only team. Actually, LFP got its start in the U.S. We're going to go through a little bit of history later, but it went through its start in the U.S. It was first commercialized in Quebec by the very team that works for Nano One through a series of acquisitions. They've ended up in our hands. So we have actually some of the oldest expertise in the space, a very small team compared to what is in China today, but a very big advantage for us in the West, particularly in North America, and will be used as a funnel to build and train much larger teams. China benefits from low-cost equipment from a manufacturing point of view, and we are leveraging our global partners not only to get access to maybe some of that equipment, but similar kind of manufacturing in Korea and other low-cost manufacturing environments. So low-cost procurement is very much an important part of our strategy. And then lastly, as I mentioned, China has put export controls on their process technology. Nano One has complete independence from that. We have 48 patents issued in the USA, in Canada, in Korea, in Japan, in China, in Taiwan, in India, and another 50 or so pending around the world. So we essentially have technology independence from China. So we have no restrictions. We're not restricted by China's export controls. The one pot process, I'm not going to go through this in a lot of detail. I think what I want you to see here is there's a lot of steps in making cathode materials from mining all the way through to the finished material. The one pot process simplifies that. We combine PCAM, which is the precursor to making the cathode material that has everything but the lithium in it. We combine PCAM and CAM process into the one pot process, and that drives down the number of steps, which drives down costs. Our engineering estimates with our engineering partners, third-party evaluation, shows about a 30% cut in OPEX and CAPEX, and 80% reduction in energy. We eliminate, as I mentioned earlier, we eliminate all wastewater, we eliminate all sulfate byproduct. GHGs go down by 50 to 60%. Process water goes down by 80%. And ultimately, we're reducing the foreign supply chain risk. All of this makes us able to make a modular design that's easier to permit, build, and operate, which reduces time to market and financial risk. This slide, we'll be sending this to you in the deck that follows, is largely a repetition of what I just said. It's just it's in writing here, so it's easier to follow when you are looking at the slides on your own. So I'm going to take you through just a little bit of history on LFP because I think it's important to understand. As I said, LFP was invented in the U.S. by a fellow named Dr. John Goodenough at the University of Texas. It was actually it was a university in Quebec that at the University of Montreal that discovered you had to carbon coat it to make it active in a battery. The first licenses were pulled in Quebec by the team that now is part of Nano One. That led to the first couple hundred tons of LFP being made in the early 2000s. Ultimately, a plant was built to service the industry in Candiac, which is a town just outside of Montreal. That plant is now in Nano One's ownership, and from about 2012 onwards, basically the process, some of the processes that were developed in the early 2000s went to China and have become the dominant way of making LFP materials there, and it grew quite organically within the Chinese framework over the last 10 to 12 years. So let's look more at recent history now. In 2021, Nano One launched an LFP strategy. We recognized that it was going to come. It was going to come to the rest of the world. It's going to come big. We could see it growing very rapidly in China. We made a bid to buy the Candiac facility from Johnson Matthey Battery Materials back in 21. We closed the deal in November of 22, and that came with the team and a plant, which are really valuable assets. In the middle of all that, Rio Tinto came in for a $12.5 million Canadian investment. That's about 5% of our market cap. 5% of our equity stack. And just to give you a sense, that was Rio Tinto came in and valued us roughly at about $300 million at the time. Since then, we've seen government financing, SDTC, Sustainable Development Technology Canada, it's a $10 million grant. That was followed by another strategic investment from Sumitomo Metal Mining, roughly about 5% of the equity stack, roughly about a $300 million valuation at the time. And that was ultimately they become a really good partner. Sumitomo Metal Mining, just to give you some context, they've been making cathode materials longer than almost anyone. They make the nickel, cobalt, aluminum cathode materials that go into Panasonic's batteries, that go into all of the early Tesla vehicles. So they're a very reputable player. They're about a 450-year-old company, and they're the most vertically integrated mining company in the battery space because they mine base metals like nickel and copper, but they go all the way to finished cathode materials as well. So quite an unusual group, but very, very talented, and we're very active with them on a weekly basis, driving towards licensing and further partnership, which we'll explain a little bit later. Worley Chemetics came online this time last year. Worley is one of the world's largest engineering firms, and we're working with them in an alliance. We're basically they're putting their time and money in, so are we to developing a plant design that can be licensed out to industrial interests. Again, more on that. There'll be more on that in the following slides. And then in the last 9 months, we've seen a whole bunch of investment from various agencies in Canada and in the US, including the Department of Defense, who invested $13 million in Nano One, the expansion of our Candiac facility. All told here, we also sold some of the land that we bought back in that original acquisition that led to about $20 million in cash coming into our bank accounts for a total of about $60 million in non-dilutive money in the last 6 months. As you all know, money is very expensive right now. The capital markets are very punishing. So that $60 million is really gold in our view and eyes. So I think that comes to the end of my slides. Alex, I think I was going to let you kind of drive it from here.
Great. Thank you, Dan. And thanks, everyone. So I'm going to touch on our business plan and how we're looking to scale our growth plans, and give you an indication of what that looks like, and then wrap it up with a little bit of our catalyst coming over the next 6 months and beyond. So just wanted to give you a sense of our two asset locations. So we have our innovation facility in Burnaby, British Columbia. This is where the one pot technology was born, and this is where we have grown our patent portfolio, and it's where a lot of the R&D happens. Um, as Dan alluded to, we have developed the technology to be a platform technology, so it's cathode chemistry agnostic, but we are focusing on the biggest mass market opportunity we're seeing, which is the LFP space. And as we innovate in Burnaby, we then work closely with our commercialization team in Quebec. This is just south of Montreal, about half an hour south of Montreal. And this is the plant that we acquired in 2022. So this is the only full-scale LFP plant outside of Asia, uh, certainly the only one in North America. And there's a huge depth of experience in supplying tier one cell manufacturers globally for 12 plus years from this facility. And it's with our technology and our know-how that we've now converted this plant to a large-scale pilot. And then we have expansion plans underway to subsequently expand it further for sales and also for demonstrating and working closely with our licensing customers that we're targeting to support them in getting offtakes for their large plants, their large volume plants, as well as to help them train and optimize their skills, their skilled workforce. Next slide. So now I'd like to talk a little bit about our scalable business model. So we have a diversified revenue stream approach. I'll start on the right first, which is the Candiac plant that we just talked about. So this is the plant that is a full-scale demonstration of our technology that we will drive offtake volumes for larger plants to be built by our licensing partners, and also that we will ultimately have some direct production revenue from for direct sales, smaller markets focused initially on defense and ESS, as those are near-term market opportunities, and while also working closely with a whole list of companies around the world to license the technology. And we feel it's important to be able to grow through licensing. One, because it's a capital light business model for us. So in licensing our technology, we're looking at upfront licensing fees as well as production licensing fees or production royalties. As part of this, we also continuously innovate and continue to add value to our licensees. So this gives some nice long-term sticky customer base that sees licensing agreements lasting 15 and 20 years. And we also partnered up with Worley Engineering that I'll talk about in the next slide to help us deploy this faster and get it to market faster. So a couple of years ago, we recognized there was one of the challenges in the sector to get to a place of having energy security and national security objectives, of having the midstream that Dan identified earlier as the primary bottleneck to achieving energy security, is the time it takes to engineer a plant, build a plant, operationalize a plant, and finally supply a customer. And we looked at that and mapped it out, and it can take 6 to 7 years from start to finish. So we have our technology advantage that Dan walked you through, and we've got our deep know-how in the space. And as we are recognizing this challenge on how do we industrialize rapidly, at the same time, our partner that we announced in May of 2024, Worley Engineering, came to us listening to their customer base, who were also struggling with cost structures of copying and pasting China methods, waste stream issues, as well as timelines it takes to get to market. And so what we've developed with Worley and are continuing to develop with them is what we call a CAM package. And essentially, that is a modular engineered design production line of our technology embedded within it, assembled in building blocks with all of the key equipment vendors engaged and prepared to supply equipment to our licensees. And they're getting essentially a feasibility level or a FEL3 level engineered production line so they can work with their local engineering partner to build out this plant. That cuts about 3 years out of that 6 to 7 years that I mentioned earlier. So not only are we bringing an economic advantage to our customer set, but we're also bringing a path to market that's much faster with all of the support that our presence in Candiac and in Burnaby can bring to these customer bases. So we think this is a faster timeline to a final investment decision, an FID. There's the support on getting the offtake, which is needed to get to FID, as well as this reduces partners' capital at risk. And so not only is the CapEx more competitive to the alternatives, but it also is a much less risky venture on the capital side because of that support. And it is a very flexible package. So what we mean by that is our customers can work either directly with us or through our alliance, and they can access varying degrees of a technology licensing package from the kind of full meal deal, full suite of support to get there with all the key equipment included in that ready-to-go package, designed in a way that they can subsequently add incremental production lines over time, all the way up to a very light package, which is just the technology license itself with Nano One ongoing support. Wanted to also give everybody a bit of a sense of the deal pipeline, the global deal pipeline that we're working with right now. So we're seeing a massive increase in defense spending budgets. These tend to be smaller volumes, but perfect size for direct sales. We're seeing a large increase in AI data center investment that is driving the need for energy storage systems. And we're also seeing more and more reliance on energy storage systems to support grid stability. And then lastly, electric vehicles. And so what we've identified here is a number of different regions where we're actively engaged with target partners, whether it's licensing partners, potential joint ventures we may struck with our technology and an industrial partner, as well as some of the direct sales customers. And really what's key to this whole space is really listening to the voice of the customer, because at the end of the day, the customer is going to drive your path to sales. And it's about working with them on their product needs, their timeline needs, their volume needs in a very collaborative way. And it's through this that we're right-sizing our growth plans to meet the voice of the customer. Next slide, if we take all of that deal pipeline and where we think there's some, higher confidence wins, as well as we look at the direct sales pipeline, the licensing pipeline, and the joint venture revenue pipeline. This is an illustrative example of how all of the building blocks that we're putting together now through the work we're doing in our facilities in Canada, through the engagement with the automotives, through the engagement with the industrial partners, are all going to ultimately come to a place where we start to deliver on these engagements that we've had. These are long sales cycles. That's really important to remember. We've been at it for many, many months with a number of these target customers, and we feel we're getting much closer to landing sales activities in each of these areas. And we also wanted to illustrate that there's essentially a stacking effect from our revenue growth path. It is multi-track. So what you see in the blue is our path to direct sales, really focused on ESS, defense applications, and sampling to electric vehicle suppliers. Dan may have alluded to earlier, we have a lot of support from the U.S. Department of Defense, who is a keen supporter of what we're doing to help establish not only LFP supply for their cell supply base, but also to help establish a secure industrial base for LFP in the US. And in the green and the technology licensing, this is a series of technology licenses representing those modular plant designs. These are attached to specific customer conversations. They're different volumes. And what you're seeing is that growth is you're seeing a mix of upfront fees starting to kick in, followed by once those assets are in production, you start to hit a steady state. And so we get this stacking effect on the licensing fees revenue. And then the joint venture revenue is an example of one plant where we envision ourselves working in close partnership with one of our collaborators, where we're the technology partner. Essentially, we have a minority interest stake in this joint venture in exchange for a lot of the sunk costs that we've made, and they're bringing the industrial operator expertise at much larger scale. And we will work with government programs that we have in place and existing government relationships and other project finance bodies to pull this together. So the JV is really an off-balance sheet opportunity where we're the technology partner benefiting from cash flows from that entity. So in sort of wrapping that part up, these are the catalysts that we see over the next, rest of 25 and into 2026. As Dan referred to, we have been very successful in the last several months to secure quite a considerable amount of non-dilutive money. So this money's come in the form of grants, interest-free loans that are long-term 10-year loans from both provincial bodies in Canada, federally from the Canadian government, as well as from the US government. To support all the activities that we're doing to bring this technology to market and really bring what we consider a leapfrog solution to competing against copying what's done in China, because we don't think that's a viable alternative, and helping secure energy for the future. We're also looking at capacity expansion in our Candiac facility to support those direct sales initiatives. We're right now in an engineering study that we'll be wrapping up soon to expand that capacity to 1,000+ tons per annum. To be honest, still small volumes in the grand scheme of things. We're talking about a multi-million-ton market opportunity that we're going after through our licensing strategy, but a very strategic 1,000 tons focused on that defense application market. That is a market that's seeing a lot of growth recently. And then we'll continue on the sampling to drive sales for larger volumes, and that'll be focused on ESS and automotive. We'll continue developing that package with Worley in our alliance. We are active in the selling of that package to different target customers around the world. And then we'll continue to develop the supply chain. So we are looking at developing supply chain relationships for those raw materials in the US and South America and Europe. And of course, we'll continue to innovate. So a big part of what we're bringing to the table here for our partners, for our shareholders, is the fact that, we're not sitting on our hands, sitting stale. We're going to continue to develop the IP patent portfolio. We'll continue to bring innovation on the process side or on the product side to help our customers stay ahead of the competition, as well as to not end up sitting on idle plants that can't keep up with market demands. And then lastly, we have a new government in Canada with very strong ties federally and provincially. We also have some fairly deep relationships in the US government side that see the need for localized supply chains and energy security. It is a national security issue. And then the European market also and the EU generally, in terms of looking to support that energy security. So maybe in wrapping up, just kind of pulling it all together. So we're looking at a $40 billion market opportunity per year by 2035. Our licensing strategy helps grab a piece of that market. It's a massive growth market driven by all the factors that we've talked about. We are active and in the room and discussing and aligning with the voice of the customer to meet their needs as things move forward. And we have a capital light licensing model. So this is about leveraging our process technology and our know-how to deploy as many licenses as possible, and leverage our expertise and our IP portfolio that is a global IP portfolio, as well as the advantages we bring economically from our technology and the energy and lower water use as well. So thanks everybody for your time. I think in wrapping up, there's a bit of a stat sheet below just to give you a sense of things, and I think we can turn it over to